The map everyone draws ends at the heliopause. The last human footprint, the last machine, the last whisper of radio. All within a bubble 30 billion kilometers across. And beyond that, nothing we can reach. That is the argument Kurzgesagt makes. It is a good argument. The distances are real, the dust is lethal, the energy costs are staggering. It's also wrong. Not in the physics. It is framing. It is the explorer's framing. The explorer looks at the interstellar void and sees a barrier. The settler looks at the same emptiness and sees something different. Open prairie. Hostile, demanding, unforgiving, but available. Room for towns, cities, nations. This video is a reply, point by point, to a Kurzgesagt video arguing interstellar travel is impossible. The question is not whether interstellar settlement is easy. It is not easy. The question is whether the arguments against it are permanent barriers or engineering challenges, and whether the settler's perspective changes that answer.
The fastest thing humans have ever built by far is the Parker Solar Probe. The probe is shooting through space at a breathtaking 635,000 kilometers an hour. So let's pretend we had a spaceship that fast with a human crew ready to explore the universe. The next stop is the end of the Oort cloud, the true edge of the solar system where open space begins. We reach it in 2,500 years.
Kurzgesagt sets the stage with distance, and the numbers are genuine. Proxima Centauri is 4 light-years away. At the speed of the Parker Solar Probe, the fastest object humans have ever built so far, the journey takes 6,700 years. The explorer sees that number and concludes, impossible in a lifetime. The settler sees that number and asks a different question. What does the ship carry? A civilization that builds orbital habitats, not space stations, habitats, has already solved the closed-loop life support problem. You're not traveling through space, you're traveling on a world you built that happens to be moving. The distinction matters. A generation ship is not a capsule full of frozen astronauts. It's a settlement. It has farms, workshops, schools, governance, parks, families. The time it takes to cross the void is not wasted, it is lived. Kurzgesagt's framing treats time as a cost, but to the settler, time is habitat design. You do not ask whether the journey is long, you design the settlement to last long enough to reach the target. Speed is expensive, and storing all you will need for the trip is also expensive. Weighing speed versus recycling efficiency becomes an optimization problem, a friendly contest between engine makers and recycling tweakers.
But you can also hit something bigger than a grain of dust, like a small rock the size of a golf ball. Hitting that at 20% the speed of light releases more than double the energy of the nuclear bomb that was dropped over Hiroshima. We'll not even talk about anything larger. Atoms, dust and pebbles are dangerous enough.
At 20% of light speed, the argument goes, even individual atoms in the interstellar medium become lethal. A grain of dust hits with the energy of a bomb. The ship erodes, the crew dies. This is true, the cost is steep when getting near light speed. It is also a physics problem stated as a veto. Every frontier has had its physics problems. Ocean-crossing ships faced storms that could swallow entire fleets. Scurvy killed more sailors than combat did. The solution was not to declare the Atlantic impossible. It was hull design, citrus, and time. The dust problem has engineering dimensions. Magnetic deflectors, physical shielding, a thick forward plate of ice or regolith that absorbs impact energy and is replaced when needed and as it ablates. Beam-powered propulsion that leaves the acceleration engine at home and saves the ship that mass. And leaves the fuel at home, that's more important. These are not magic, they are hard. But hard is not the same as impossible, and Kurzgesagt's framing conflates the two. There is a deeper assumption here worth surfacing. The dust argument assumes that the ship travels fast. It assumes a 20% light speed sprint because that is what makes the journey a human lifetime project. But remove the human lifetime constraint, settle the ship, and the speed requirement drops to an optimization problem with recycling. At 1% of light speed, dust is no longer a bomb, it's a maintenance problem. And maintenance problems are what settlements do.
Almost everything in space that's close is super lame. The first proper target out.
Kurzgesagt surveys the neighborhood and find it hostile, boring, and dull. Red dwarf stars flare. Planets are tidally locked. Radiation bathes the surface. Nothing looks like Earth. The conclusion: there is nowhere worth going, worth seeing. This is the explorer's definition of worth. The explorer wants to walk outside, breathe the air, see the sights. The settler builds walls and fills them with air. The resources that matter to a settlement are not blue skies and liquid oceans. They are what we call the bones: iron, aluminium, silicon, magnesium, titanium, the structural elements present in any solid rock. And the volatiles, which we call breath: hydrogen, carbon, nitrogen, oxygen, present wherever there is atmosphere, cold traps, or a history of carbonaceous impacts. A red dwarf system with rocky debris is not uninhabitable. It's currently lifeless. The distinction is everything. You do not need a habitable planet. You need habitable volumes, sealed, pressurized, shielded environments that you construct from local material. A tidally locked world with flaring radiation is a problem for a surface colony on the sunny side. It is not a problem for a subsurface habitat or a shielded orbital cylinder fed by asteroid mining. The solar system is full of places the explorer calls dead. The settler calls them building sites.
In 1903, the New York Times published an editorial, Flying Machines Which Do Not Fly, that confidently predicted it would take humans 1 to 10 million years to achieve powered flight. 69 days later, the first successful flight happened. 66 years later, humans landed on the moon.
And then Kurzgesagt does something interesting. After spending 12 minutes explaining why we cannot leave, it walks its own argument back. The 1903 New York Times predicted flying machines would take 1 to 10 million years to develop. The Wright brothers flew 9 weeks later. Kurzgesagt includes this historical humility to soften its conclusion, but it inadvertently makes the settler's case. Technology compounds, not linearly, exponentially, along mutually reinforcing lines. Better materials enable better propulsion. Better propulsion enables larger payloads. Larger payloads enable in-space manufacturing. In-space manufacturing removes the gravity well as a constraint. Each step unlocks the next. The argument that interstellar travel requires overwhelmingly transformative technology is sort of true. It is also true that every transformative technology in human history looked impossible until it existed. Controlled fire, agriculture, the steam engine, electricity, nuclear fission, each was, in its moment, overwhelming. This is not an argument from optimism, it's an argument from pattern recognition. Every frontier that physics permitted, humans settled. The physics of interstellar space are not kind, but they are not prohibitive. They are difficult, and the difference between prohibitive and difficult is what separates the explorer's conclusion from the settler's view. Kurzgesagt asked why humanity will never leave the solar system. The settlers answer: because we have not yet built the ship. But the materials are there. The physics permits it. The timescale is long. Longer than any human project ever attempted. But settlements are not projects, they are places. And places persist. The explorer leaves footprints and brings home pictures. The settler stays and brings a home to the new place. The settler builds. The settler looks at the emptiness between the stars and sees not a wall, but an invitation. If you want to know where this goes next, our rambles and other stories take the common question and push the boundary.